Hello friends, welcome back to my channel. Today I would like to talk about the concept stoichiometry. First, let's see about the symbols of the elements. Each element is represented by its own unique symbol as seen on the periodic table. Example, H is hydrogen. Where a symbol contains two letters, the first one is always in capital letters and the other is small. Example, sodium is Na, not capital N and capital A. Atoms combine together in fixed ratios that will give them full outer shells of electrons. The chemical formula tells you the ratio of atoms. Example, H2O is a compound containing two hydrogen atoms which combine with one oxygen atom. Chemical formulae. The structural formula tells you the way in which the atoms in a particular molecule are bonded. This can be done by either a diagram, displayed formula, or written simplified structural formula. The molecular formula tells you the actual number of atoms of each element in one molecule of the compound or element. Example, H2 has two hydrogen atoms, HCl has one hydrogen atom and one chlorine atom. The empirical formula is the simplest whole number ratio of atoms present in a compound. Example is shown here. For butane, structural formula, displayed formula, structural formula, simplified formula, molecular formula, empirical formula, all are shown over here. How to deduce a formula? The chemical formula can be deduced from the relative number of atoms present. Example, if a molecule contains 3 atoms of hydrogen and 1 atom of nitrogen, then the formula would be NH3. Diagrams or models can be used to represent the chemical formula NH3. How to deduce a formula of an ionic compound? The concept of valency is used to deduce a formulae of compounds, either molecular compounds or ionic compounds. Valency or combining power tells you how many bonds an atom can make with another atom or how many electrons its atoms lose, gain, or share to form a compound. Example, carbon is in group 4, so a single carbon atom can make 4 single bonds or 2 double bonds. The valency can be deduced from the group number. Group number 1 has valency of 1, group number 2 valency of 2, group 3 valency 3, group number 4 valency 4, group number 5 valency 3, group number 6 valency 2, group number 7 valency 1. How to write the formula of aluminium sulfide? First, write out the symbols and write their valencies, Al and S. The formula is then calculated by cross-multiplying each atom with the number opposite. Therefore, the formula is Al2S3. Compound ions. As well as simple ions of elements, there are some common ions which contain two elements combined together. These ions are known as compound ions. Here are the names and formulae of some compound ions. NH4 plus is ammonium, NO3 minus nitrate, SO4 2 minus sulfate, CO3 2 minus carbonate, PO4 3 minus is phosphate. Calcium nitrate formula and potassium sulfate formula is shown over here. Names of compounds. For compounds consisting of two atoms, if one is a metal and the other a non-metal, then the name of the metal atom comes first and the ending of the second atom is replaced by adding IDE. Example, NaCl, which contains sodium and chlorine, thus becomes sodium chloride. If both atoms are non-metals and one of those is hydrogen, then hydrogen comes first. Example, hydrogen and chlorine combined is called hydrogen chloride. For other combinations of non-metals, as a general rule, the element that has a lower group number comes first in the name. Example, carbon and oxygen combine to form carbon dioxide since carbon is in group 4 and oxygen is in group 6. For compounds that contain certain groups of atoms, there are common groups of atoms which occur regularly in chemistry. Examples include the carbonate ion CO3 2 minus, sulfate ion SO4 2 minus, hydroxide ion OH minus, and the nitrate ion NO3 minus. When these ions form a compound with a metal atom, the name of the metal comes first. Example, KOH is potassium hydroxide, CaCO3 is calcium carbonate. H2SO4 is sulfuric acid, which is hydrogen sulfate. HCl is hydrochloric acid, which is hydrogen chloride. HNO3 is nitric acid, which is hydrogen nitrate. H3PO4 is phosphoric acid, which is hydrogen phosphate. Equations. The first one is word equations. These show the reactants and products of a chemical reaction using their full chemical names. The arrow implies the conversion of reactants into products. Reaction conditions or the name of a catalyst can be written above the arrow. An example of a word equation for neutralization is sodium hydroxide plus hydrochloric acid gives sodium chloride plus water. Symbol equations. Chemical reactions can be represented using symbol equations. In a symbol equation, substances are written using their chemical symbol or formula. State symbols are used in symbol equations to show whether each chemical is a solid, liquid, gas, or solution. State symbols are written after the formula of each substance. Solid, state symbol S. Liquid, L. Gas, G. Aqueous solution, AQ. For example, compare the word equation below with its symbol equation. Magnesium carbonate plus sulfuric acid gives magnesium sulfate plus water plus carbon dioxide. MgCO3 plus H2SO4 gives MgSO4 plus H2O and CO2. The symbol equation shows that solid magnesium carbonate reacts with a solution of sulfuric acid to produce a solution of magnesium sulfate plus liquid water and some carbon dioxide gas. Writing balanced ionic equations. In aqueous solutions, ionic compounds dissociate into their ions. Dissociation is the separation of ions when a soluble ionic compound dissolves in water. Insoluble ionic compounds do not dissolve in water. This means that their ions are not dissociated. These are the solubility rules. Group 1 ions, sodium ion, potassium ion, all are soluble. Ammonium ion, all are soluble. Nitrate ion, soluble. Halide ions, chlorides, bromides, iodides, all are soluble except silver halides and lead halides. Sulfate ions, all are soluble except barium sulfate, calcium sulfate, and lead sulfate. Carbonates, all are insoluble except sodium carbonate, potassium carbonate, ammonium carbonate. Hydroxide, all are insoluble except sodium hydroxide and potassium hydroxide. Example, write the ionic equation for the reaction of aqueous chlorine and aqueous potassium iodide. Step 1. Write out the full balanced equation. Step 2. Identify the ionic substances and write down the ions separately. Step 3. Rewrite the equation eliminating the ions which appear on both sides of the equation, which is called spectator ions, which in this case are the potassium ions. So the net ionic equation is Cl2 plus 2I minus gives 2Cl minus and I2. Ionic equations for neutralization. The ionic equation for the neutralization of hydrochloric acid with sodium hydroxide is shown as below. HCl plus NaOH gives NaCl plus H2O. Cancel off the spectator ions gives you the ionic equation for the neutralization as H plus OH minus gives H2O. Another example is shown here. MgSO4 plus BaNO3 twice gives MgNO3 twice plus BaSO4. The net ionic equation is Ba2 plus SO4 2 minus gives BaSO4. Relative masses of atoms and molecules. Relative atomic mass AR is the average mass of an atom of an element compared to the 1/12 the mass of a carbon-12 atom. Relative formula mass MR of a substance. The sum of the relative atomic masses of the elements present in the formula unit. If the substance is made of simple molecules, this mass may be also called the relative molecular mass MR. Example, hydrogen, MR of hydrogen is 2 times 1, 2. Water, MR of H2O, 2 times 1 plus 16 equals 18. More examples are shown over here. First example is hydrogen, carbon dioxide, then calcium carbonate, ammonium sulfate, hydrated magnesium sulfate. Let's see percentage by mass. The percentage by mass of a particular element in a compound can be found from calculations of relative formula mass. This type of calculation is useful, for instance, in estimating the efficiency of one fertilizer compared with another. For example, what percentage of mass of NH4NO3 is nitrogen? First, MR value is calculated as 80. Percentage mass of nitrogen is calculated as 28 over 80 times 100, which is 35%. Compound formation and chemical formulae. A particular compound always contains the same elements. These elements are always present in the same proportions by mass. It does not matter where the compound is found or how it is made. These proportions cannot be changed. Example, magnesium reacts with oxygen to form magnesium oxide. Work out the reacting masses and the product mass. 48 grams of magnesium react with 32 grams of oxygen to form 80 grams of magnesium oxide. The mole and the Avogadro constant. The mole, symbol MOL, is the SI unit of amount of substance which has a mass equal to its relative formula mass in grams. It contains 6.02 times 10 to the power 23, which is the Avogadro constant. Atoms, molecules, or formula units depending on the substance considered. Example, 1 mole of sodium contains 6.02 times 10 to the power 23 atoms of sodium. 1 mole of hydrogen, H2, contains 6.023 times 10 to the power 23 molecules of hydrogen. 1 mole of sodium chloride, NaCl, contains 6.02 times 10 to the power 23 formula units of sodium chloride. Calculations involving the mole. Number of moles equals mass over molar mass, where the mass is in grams and the molar mass is in grams per mole. The triangle shown below can be a useful aid to memory. Example, how many moles are there in 60 grams of sodium hydroxide? Use the formula, number of moles equals mass over molar mass. The moles is being calculated as 1.5. Another example, what is the mass of 0.5 mole of copper 2 sulfate crystals? Calculations is shown over here. Using the mole to determine empirical and molecular formulae. The empirical formula is the simplest whole number ratio of the atoms of each element present in one molecule or formula unit of the compound. For example, in ethane C2H6, the ratio of the number of carbon to hydrogen atoms is 1:3. The empirical formula is CH3. For hydrogen peroxide H2O2, where the simplest ratio is 1:1, the empirical formula is HO. Steps to find the empirical formula. Step 1. If given the percentage composition, assume a 100-gram sample, then convert percentage to grams. Step 2. Use the atomic masses to convert grams to moles. Step 3. Divide the moles of each element by the smallest mole fraction. Step 4. The results from step 3 should be a whole number. If not, make it so by multiplying a common factor. Example, a hydrocarbon is found to contain 4.8 gram of carbon and 1 gram of hydrogen. Calculate its empirical formula. AR of carbon is 12 and AR of hydrogen is 1. Steps are shown over here and the formula is C2H5. Another example, 3.2 gram of sulfur reacts completely with oxygen to produce 6.4 gram of an oxide of sulfur. Calculate the empirical formula of the oxide of sulfur. AR of sulfur is 32, AR of oxygen is 16. The steps are shown over here and the formula is SO2. A compound is found to contain 63.52% iron and 36.48% sulfur. Find its empirical formula. The formula is being calculated as FeS. How to determine the molecular formula from the empirical formula? You must be given the empirical formula and the molecular mass. Calculate the empirical mass. Divide the molecular mass by the empirical mass. Multiply all subscripts by the answer in step 2. Example, a white powder is analyzed and found to have an empirical formula of P2O5. The compound has a molecular mass of 283.88. What is the compound's molecular formula? Step 1, find the molar mass. Step 2, divide molar mass by empirical formula mass. Step 3, multiply. Hence, the molecular formula is P4O10. Molar gas volume. At a given temperature and pressure, 1 mole of any gas occupies the same volume. The molar volume is the volume occupied by 1 mole of any gas at room temperature and pressure. The molar volume is equal to 24 dm cubed or 24,000 cm cube. Amount of gas in mole equals volume of gas in dm cube over 24 or volume of gas in cm cube over 24,000. Example, calculate the volume of 0.25 mole of hydrogen at room temperature and pressure. Molar volume is equal to 24 dm cube. Volume equals moles times molar volume, which gives you 6 dm cube. Try this example. Calculate the amount of carbon dioxide that occupies 120 cm cube at room temperature and pressure. Molar volume equals 24,000 cm cube. The answer is 0.005 mole. The next subtopic is moles and concentration. The concentration of a solution is usually expressed as the amount of solute moles dissolved in a given volume dm cube of solution. Concentration in mole per dm cube equals mole over volume in dm cube. Mass and concentration. The concentration of a solution can be measured in grams per dm cube or moles per dm cube. The following equation gives concentration in gram per dm cube. Concentration in gram per dm cube equals mass dissolved in grams over volume of solution in dm cube. The relationship between mole per dm cube and gram per dm cube is shown over here. Concentration in gram per dm cube equals concentration in mole per dm cube times molar mass. Example, 0.5 mole of sodium hydroxide is dissolved in 2 dm cube of water. Calculate the concentration of the sodium hydroxide solution formed. Concentration has been calculated as 0.25 mole per dm cube. Hundred centimeter cube of dilute hydrochloric acid contains 0.02 mole of dissolved hydrogen chloride. Calculate the concentration of the acid in mole per dm cube. Please try this question. Answer is given as 0.2 mole per dm cube. Next question, if 1 gram of solid sodium hydroxide is dissolved in 250 centimeter cube of solution, what is the concentration in gram per dm cube? Please try this also. The answer is shown over here as 4 gram per dm cube. Another example, a bottle of medicine contains 120 milligram of paracetamol in 5 cm cube of solution. What is the concentration in gram per dm cube of paracetamol in the medicine? Try this. Answer is 24 gram per dm cube. Another example, calculate the concentration of 7.3 gram per dm cube hydrochloric acid in mole per dm cube. MR of HCl equals 36.5. Please try this example. And you get the answer as 0.2 mole per dm cube. Another example, the concentration of a solution of a bottle of HCl is 73 gram per dm cube. How many moles of HCl are there in 250 cm cube of this acid? Please try this example. Answer is 0.5 mole. The next subtopic is limiting reactants. A reaction finishes when one of the reactants is all used up. The other reactant has nothing left to react with, so some of it is left over. The reactant that is all used up is called the limiting reactant. It sets a limit on how much product can form. The reactant that is left over is described as being in excess. The mass of product formed in a reaction depends upon the mass of the limiting reactant. This is because no more product can form when the limiting reactant is all used up. Example: how much aluminum chloride is formed when 2.7 gram of aluminum are reacted with 9.125 gram of HCl. 2Al plus 6HCl gives 2AlCl3 plus 3H2. The steps are given over here. First, convert mass into moles for both reactants. Now use the moles of the limiting reactant to calculate the mass of the product. Remember to use the molar ratio between the limiting reactant and the product. And hence you can find out the mass of aluminum chloride. Take the reaction NH3 plus O2 gives NO plus H2O. In an experiment, 3.25 gram of NH3 are allowed to react with 3.50 gram of O2. Which reactant is the limiting reagent? How many grams of NO are formed? How much of the excess reactant remains after this reaction? Please try this question. Answer is given over here. Limiting reagent is O2. How many grams of NO are formed? Answer is 2.63 gram NO. And 1.76 gram NH3 is left. Another example, if 4.95 gram of ethylene C2H4 are combusted with 3.25 gram of oxygen, what is the limiting reagent? How many grams of CO2 are formed? Please try this example. And limiting reagent is oxygen. Amount of carbon dioxide formed is 2.98 gram CO2. What is the limiting reactant if 2.2 gram of magnesium is reacted with 4.5 liter of oxygen at STP? The reaction is 2 Mg plus O2 gives 2 MgO. Please try this. The answer is magnesium is limiting and oxygen is in excess. Calculations using titration. Titrations are a method of analyzing the concentration of solutions. Acid-base titrations are one of the most important kinds of titrations. They can determine exactly how much alkali is needed to neutralize the quantity of acid and vice versa. A solution of 25 cm cube of hydrochloric acid was titrated against a solution of 0.1 mole per dm cube NaOH, and 12.1 cm cube were required for complete reaction. Determine the concentration of the acid. Step 1. Write the equation for the reaction. Step 2. Calculate the number of moles of NaOH. Step 3. Deduce the number of moles of the acid. Step 4. Find the concentration of the acid. Next example. In a titration, 25 cm cube of 0.1 mole per dm cube sodium hydroxide solution is exactly neutralized by 20 cm cube of a dilute solution of hydrochloric acid. Calculate the concentration of the hydrochloric acid solution. Please try this question. The answer is 0.125 mole per dm cube. Next example. In a titration, 25 cm cube of 0.2 mole per dm cube sodium hydroxide solution is exactly neutralized by 22.70 cm cube of a dilute solution of hydrochloric acid. NaOH plus HCl gives NaCl plus H2O. Calculate the concentration of the hydrochloric acid. You can try this. Answer you're getting is 0.220 mole per dm cube. Theoretical, actual, and percentage yield. Yield is a term used to describe the amount of product you get from a reaction. In practice, you never get 100% yield in a chemical process for several reasons. These include some reactants may be left behind in the equipment. The reaction may be reversible. Some products may also be lost during separation and purification stages. There may be side reactions occurring where a substance reacts with a gas in the air or an impurity in one of the reactants. Products can also be lost during transfer from one container to another. The actual yield is the recorded amount of product obtained. The theoretical yield is the amount of product that would be obtained under perfect practical and chemical conditions. It is calculated from the balanced equation and the reacting masses. The percentage yield compares the actual yield to the theoretical yield. For economic reasons, the objective of every chemical producing company is to have as high a percentage yield as possible to increase profits and reduce cost and waste. To calculate percentage yield, the following equation is used. Percentage yield equals actual yield over theoretical yield times 100. Example, copper sulfate may be prepared by the reaction of dilute sulfuric acid on copper oxide. A student prepared 1.6 gram of dry copper 2 sulfate crystals. Calculate the percentage yield if the theoretical yield is 2 gram. Actual yield of copper sulfate is 1.6 gram. Percentage yield of copper sulfate is 1.6 over 2 times 100, which is equal to 80%. You have to try this question. 12.4 gram of copper 2 carbonate are heated and decomposes. 6 gram of copper 2 oxide is formed. Calculate the percentage yield. The answer you are obtaining is 75%. Another question. If 2.5 gram of K3PO4 was produced in the reaction below and the percentage yield was 45%, what was the theoretical yield? Please try this question. And you get the answer as 5.6 gram. Next subtopic is percentage purity. A pure substance has nothing else mixed with it. Often, the product you are trying to obtain may become contaminated with unwanted substances such as unreacted reactants, catalysts, and other impurities. To calculate the percentage purity, the following equation is used. Percentage purity equals mass of pure substance over total mass of substance times 100. An example is shown over here. A sample of lead to bromide was made. It weighed 15 gram. The sample was found to be impure and only contained 13.5 gram of lead to bromide. Calculate the percentage purity of the lead to bromide. Total mass of the substance 15 gram. Mass of pure substance 13.5 gram. To calculate the percentage purity, 13.5 over 15 times 100, which is equal to 90%. You can try this question. Calculate the percentage purity of a sample of magnesium hydroxide if titration of 2.568 gram of the sample required 38.45 cm cube of 0.6695 mole per dm cube H3PO4. The answer for this question is 87.7%. That's all. Thank you so much for watching this video.